So in the last video we talked about tokenization and embedding. So now we're going to do those in code. Here we have this code which actually downloads this file called the verdict.txt. In the file name the verdict.txt. Okay, and then we open that here as in read mode, and we're going to read that text file, and this f.read actually returns the whole text in one string. Okay, and that one string, that single string, right? And that single string is actually assigned to raw underscore text. So raw underscore text, this variable has it becomes this string which contains the content of this file. Okay, and then so when you look at the number of characters here, the number of characters, total number of characters in this the contents of the verdicts.txt is 20,479. So there are these many characters in that file, the contents of that file. And here we are we're printing only 0 to 99, 98 rather, 0 to 98 characters. Okay, so first 98 characters. So I had always thought Jack Gisborne, rather cheap genius, and so on. Okay, so the goal is to tokenize and embed this text for an LLM, because we're gonna code an LLM from scratch. So we're gonna use a text file just like this in order to train that LLM, which is the large language model. Okay, let's develop a simple tokenizer based on some simple sample text that you can later apply to the text above. Okay, so here this is a regular expression, and here's the text. Text is hello world. This is a test, and then we're going to use this pattern, and then from here the result is this. So that means this text is broken into these different tokens, right? So hello comma, this is one token, this is space, world dot space, and so on. Okay, and we just don't want to split on white space only, so we need to break these. So as you can see here, the comma is still part of this word hello, right? Because there's no space between hello and comma, so this comma didn't come out as a as a separate token. So what we can do is we can take care of that here. So that means now in this case we're using a different pattern, and this one actually splits even the punctuation, like comma, the period, and so on. Okay, and so out of those, so we want to discard all these spaces, right? So for that, okay, we use this. So as you might know, so this is comprehension, list comprehension. So because you're gonna loop through this item by item, and then so when we strip that, for example, when we strip. So for example, we strip this. Stripping means removing the leading and the white space on the front of the item, that token, and the towards the back of the token. Okay, so basically when you strip it, all these empty spaces, these spaces are gone. Okay, when you strip them, it is null. So when you strip this empty string, then it becomes null, so it's not included in this result. Okay, so here it's kind of filtered out. So this is filtered out, and then that's why we get this It's the same result just like above, but without the spaces. So yeah, this is much better than this one up there. Okay. So now what we're going to do is, this looks pretty good, but let's also handle other types of punctuation. So we might have, say, periods, question marks, and so on. So we're going to take care of all those. So now if in your text there are different kinds of punctuations. So they are all tokenized like this. So now here it's nicely tokenized. So as you can see, hello, comma, word, period, is this dash dash a test, question mark. So there are different kinds of different punctuations, and then you can see there that these words are, see, these are word tokens. These are word tokens right there, and you have punctuation tokens, comma, comma, period, and so on. Okay. So now we're ready to apply this tokenization to the raw text. So here, for example, if you have input text, hello world, is this dash dash a test? Okay, so just like this one up there. So once you tokenize using this code right here, this regular expression, so it turns out to be this one. Okay, this is the output. Okay, so now we can do pre-process equal re.split. Okay, here is pre-processed, and then now this is list expression. And then here, so basically we're taking the raw text is this one that we read previously, this one right here, raw text, which is read right here, means the content of the verdict.txt that we downloaded. Okay, so now here what we're doing is we are actually pre-processing it so that the string is turned into tokens, right? A list of tokens right here. Okay, so and we're showing only the top 30 of them. Okay, the 30 tokens we're showing, and there are many more, of course. And here, let's calculate the total number of tokens. The total number of tokens is 4,690. Okay, now so what we did was we just we downloaded a text file, and then we actually tokenized the contents of the file, and then the first 30 characters of that tokenized result is shown here. Okay, so now the next thing is we need to convert tokens into token IDs. Okay, that's the next step. So this is what we're going to do. So if you look at the figure right here, you can see step 1 is tokenization, which breaks down the training set into individual tokens, just like we did up there. Okay, so this is the complete training data set there. So it might be a huge data set, many sometimes millions of files, hundreds of thousands or millions of files, right? So for example, here this input text might be the quick brown fox jumps over the lazy dog, and the training set consists of only one sentence per illustration, just for illustration purposes, right? Okay, so then the tokenized training set is this one. So this has been tokenized, this sentence has been tokenized here. And step 2 is each unique token is added to the vocabulary in alphabetical order. Okay, so basically now once it is tokenized, then this is sorted by alphabetical order, right? Sorted alphabetically. Okay, and then each one is given a unique integer ID. Okay, for example, first comes brown and its integer ID is 0, and then dog gets the integer ID 1, fox gets the integer ID 2, and so on. Okay, so now this is called the vocabulary. Okay, so this is the vocabulary of the training set. Okay, and these are the corresponding token IDs. Okay, now we can now build a vocabulary that consists of all unique tokens. Okay, so this is done right here. So let's see. All words is equal to sorted set preprocessed. So preprocessed is the list of tokens. This is the list of tokens that we created here. So this is the list of tokens, and we're going to turn that list to a set. So when we do that, we get unique tokens. Okay, so there might be duplicates and this pre-process might have duplicate tokens, but when we do set, where we get only unique tokens, and then we sort them. Okay, so sort this. So now all words, and then we put it in the variable all words. And that's the vocabulary. Actually, this is the vocabulary, right? And then the vocab, so what's the size of the vocab? The vocab size is equal to the length of all words, right? Then, so when we print vocab size, we get 1130. Okay, and now vocab, so what we're going to do is we're going to turn this, so we have right up here, up until here, vocab, all words means all the unique words, which is the vocabulary, and then now we need to give each one of them, so that means we got up until here, so now we're gonna have to give integer IDs to each of these tokens, right? So this is done right here using a set comprehension. So this is a set comprehension, and here we're running it in a loop. Okay, so where we enumerate all words, that means enumerate gives you the index as well as the word or token, index comma token, right? And then index goes into integer, right? And the token goes into token, this variable. And then here we build a dictionary rather, right here. So it's so actually it's a dictionary comprehension. So I said set comprehension, but actually it's a dictionary comprehension. So it's a so now vocab becomes now this returns a dictionary of all the tokens with their corresponding integer values. Okay, and that is put in the variable vocab. So vocab is now vocab contains this. This is vocab right here. So this is vocab. After that step, after we run that code, then we get this vocabulary, which is vocab, right? Okay, so that's vocab, and if we print the first 50 items of the vocab, this is how it looks like. So this first all the punctuations, right? And then first this punctuation exclamation mark gets the integer ID 0, token ID 0, this double quote, token ID 1, single quote, token ID 2, and so on. Okay, and here just top 50 tokens with their corresponding integer IDs or token IDs are shown here. Okay. Now we illustrate the tokenization of short sample text using a small vocabulary. So now we have the vocabulary ready, right? Vocabulary, as you have seen, that vocabulary contains the unique words sorted in alphabetical order, and then each of the words are token. A token means that it might have punctuation as well, right? So they get a unique integer ID, right? And then here it's shown in the figure. Let's see. Here what we're going to do is we can take the sample text, we're going to tokenize it, right? And then we reference this vocabulary, and then with reference to this, we look up the values for, say, for example, the integer ID of the, and then we get 7. The integer ID of brown is 0 in this example, and dog is 1, and so on. Okay, so basically here we can take this sample text, which is a sentence, break it down into tokens, right? And then tokens are now converted into individually, token by token, or word by word, or token by token, including the punctuation as well. So they are looked up. Okay, the values of each of these individual tokens are looked up in the vocab, and then this tokenized sample text is turned into the corresponding token IDs. So here's the code. So in this code, we're creating a class called simple tokenizer v1, and here's the constructor, which takes vocab as the argument. Okay, and then here separate str to int is equal to vocab. So str to int is vocab, because vocab helps you convert some text, okay, into an integer ID or token ID. Okay, And likewise, sub.int is str is a dictionary. So here we can take each of the vocab items one by one, and we turn it into a dictionary. So we have so each of these this will give us vocabulary items, gives us the string, this token, and the ID, right? So token goes to S, and ID goes to I, and then it's flipped here. So it maps the ID to token, Okay, so so that if you give it an ID, so if you in this dictionary, so the keys are the IDs, and the values are the corresponding tokens. Okay, and likewise we have encode. Encode, actually what it does is it turns text into IDs. You give it a text, for example a string, and it will turn that into corresponding IDs, like going from here to here. Okay, that's encode. And decode does just the opposite. Okay, what it does, it takes IDs, a string of IDs, or a series of IDs, right, or list of IDs, whatever, and then it's converted to corresponding text by looking up this vocabulary. Okay, this which is a dictionary. Okay, and here let's look at the encode and decode functions in figure. So here you can see the encode here, sample text. Okay, encode, what it does is it takes sample text, tokenize, and turn it into tokens, token IDs rather. Okay, series of token IDs. So by referencing the vocabulary or looking up the vocabulary, and the decode. This is decode. What decode does, it takes the token IDs. Okay, and then using inverse dictionary, which is right here, into str. Okay, and then it turns these tokens into the integer tokens, token IDs, into corresponding tokens, and then they are combined to form a sentence. Okay, so these are complementary functions, encode and decode. And you can use the tokenizer to encode, that is, okay, tokenize text into integers, and these integers can then be embedded as input of or for the LLM. Okay, so tokenizer, let's see, let's try to use this class right here, this class that we just saw. Okay, so here what we're going to do is here we are instantiating this class and this is the we're providing vocab as the argument to the constructor, and the text is the last he painted, and this. Okay, and then so the IDs are tokenizer.encode. So what we're doing is we're calling this encode method. Okay, and then tokenizer, which is the instance of simple tokenizer, if you want. And then when you encode text, you get back what? IDs, right? And then here these are the corresponding IDs. So all these are broken into tokens, and each of these tokens are given integer IDs based on or by referencing the vocab, right? Vocab dictionary. Okay, and we can decode the integers back into text using tokenizer.decode, and we give these IDs, and what we get back is the same text, which is the inverse operation, right? Decode is the inverse of encode, and we get the tokens back. And then okay, so basically we get these converted back to the sentence that we started out with. Okay, so here what we're doing is we're encoding some text, and the result is decoded, and we get back the same text as you see here.